Hello everyone. Through this video, we'll discuss the most important concept of Java, that is a thread and its life cycle in Java. So before going to the concept, let us understand what is thread is all about. Okay. So for example, suppose I am conducting one exam duty for students and there are four columns of students are sitting. I have given the responsibility to distribute the question paper. Okay. So suppose I'll consume 5 minutes to distribute the question paper for one column. So to complete the entire task in the exam hall, I need 20 minutes. Okay. To reduce the workload and to reduce the time consumption, what I have done, I have taken the help of four students and given the question paper to distribute individual columns. Okay. So now suppose every student will also consume 5 minutes to distribute the question paper for individual column students. Now here, after following this principle, I am total consuming 5 minutes to distribute the question paper to entire students. So what I have done here, so whatever the task is given to me, I have divided into four subtasks and executed parallelly. Okay. So every student is now treated as one thread. Clear? So this is known as the concept of multi-threading. So whatever the task is given to me, I have divided into number of subtasks and executed parallelly to utilize the resources which is given to me effectively. Okay. So this is, you can say, multi-threading. So through this concept, you will know how the execution can be faster for a Java program. Okay. So let us discuss one by one the step through example. Okay. So what is multi-threading is all about? For example, suppose one examination section or conduction of examination is one task for the institute. Okay. Now here, question preparation, then invigilation and evaluation. Now the entire task of examination is divided into three sub processes. Okay. Now for example, invigilation, there is a possibility that I can do for each branch on individual day by a single faculty or single staff. Okay. For example, suppose computer science students, they are having, suppose 300 students are available. Okay. 300, and we are suppose having five sections. Okay. Now if I am doing the invigilation duty for 60 students at a time, then I need one staff. Okay. So if I'll do sequentially for 60 students, then for first 1 hour, I'll do the invigilation for 60 students, second hour for next 60 students, third hour for next 60 students, fourth hour for next 60 students, and fifth hour for next 60 students. So I'm consuming 5 hours to do the invigilation for the 300 students of CSE. Okay. But what we have done, we have divided the entire invigilation duty into four different threads. Okay. Or you can say five different threads for your requirement. Okay. Now 60 students are allocated to one staff, 60 students are allocated to another one, 60 students are allocated to third one, fourth one, and fifth one. Okay. Now if I'll allocate five different staffs to do the invigilation duty for individual 60 students. Now parallelly, within 1 hour, I am completing the invigilation duty for all CSC students. Okay. So for that, we are not consuming some any extra memory. Okay. So for suppose invigilation duty, five rooms are allocated. Okay. Now five teachers are allocated. And suppose water bottle, the fans, room lights, whatever the resources you can think, that everything is allocated for the invigilation duty for process 2. Okay. Now process 2 has divided its process into number of threads or sub processes, and all threads are sharing the same resources which is allocated to process 2. They are not getting any extra resources as per their requirement, but whatever the resources are allocated to process 2, those resources are shared by all the threads. Okay. So to make parallel execution or to consume less memory or for faster execution in Java, multi-threading has come. Okay. So by using multi-threading, you are dividing the entire program into sub programs to execute parallelly for faster execution. Okay. So hope this example will make you clear what is multi-threading is all about. Okay. So let's discuss why multi-threading is actually required. So multi-threading actually allows parallel execution, the most important point, of two or more parts of a program. So a single program is divided into two or more sub-programs for parallel execution. Okay. So thread is a lightweight process. This is very important point. Thread is a lightweight process. Why thread is known as lightweight process? Because they share all the memory and resources available to the process. Like we have given the example, what we have divided process 2 into number of threads. But whatever the memory is allocated or resources are allocated to process 2, everything is shared by different threads. Okay. So that's why it is known as one thread is known as lightweight process. Now why again it is required? Because maximum utilization of CPU. If any organization is having 5 rooms, then why the invigilation duty will be done in a single room? Other 4 rooms will be idle or that will be wastage. So to utilize the resources, we are conducting multi-threading or parallel invigilation duty can be conducted. Okay. Similarly, CPU is available in the computer. Now for maximum utilization of the resource or CPU, multi-threading is required. Okay. Now again, threads are independent of each other. Whenever any staff is conducting invigilation duty in room number 1, they are independent of room number 2, room number 3, room number 4, and room number 5. Okay. So whatever the problem is occurring, suppose any problem, question paper is not available in room number 2, but that is not going to affect room number 1, room number 3, or room number 4, or room number 5. Okay. So threads are independent of each other with respect to exception in any other thread. Any problem is occurring in any thread, that is not going to affect other threads. Okay. So here parallel execution can be done for maximum utilization of resources or CPU, and all are independent of each other during execution. Clear? Now we'll come to life cycle of a thread. So life cycle of a thread means what? One thread can be in any of the 5 states. 5 states means new state, runnable state, running state, block state, and terminate state. So one thread can be present in any one of the states in its lifetime. Okay. So if we'll take the example, let's understand this one. Okay. Now suppose you have taken admission. You have taken admission, it doesn't mean you will directly get a job. Okay. So from taking admission to get a job, there are a number of process are there. You have to complete all the processes. Okay. Now what you want to, what are the processes? Now for example, the industry interface cell will provide you job opportunity. Okay. So to reach to that particular cell, you have to declare yourself that I am ready with all the activities. That means I don't have any backlog. I know few programming languages like C, C++, most importantly Java, Python. So all the programming languages I am clear. I know what is database operations. Okay. I know what is data structure. So after completing all these things, now you will declare yourself that I am ready for placement or to appear in front of the interviewer. Okay. Now whenever you will declare yourself ready means you are ready with all the activities. Clear? Now the ISL people, they will find one student and will allow for job interview. Now suppose you will crack the interview, you will get a job. Now your process is over. Okay. But if you are not getting the job, that means some lacking is still there. So you have to again go for preparation. Okay. Now during the interview, suppose the interviewer has, you have declared yourself ready that I know these many things and I am ready. Now the interviewer will ask you, have you done any project in Java? You'll say no. That means you are still lacking with some resources. Okay. Then you will be told to do some more preparation and again appear for interview. So that means during the job interview also you are told to go to waiting state. Why? Because in the waiting state you have to do some preparation. Clear? Okay. So by keeping everything in mind, let's discuss this diagram. Okay. Now whenever any thread is being created, okay, any thread is created, they are known as new, they are in the new state. Okay. And that is also known as thread pool. Clear? Where multiple number of threads will be created because number of students will take admission. Suppose around 600 students are taking admission, so all will be treated as new thread and available inside the thread pool. Clear? Now by calling the start method to individual thread, you are making them to ready for execution. That means they will come to a runnable state, and any thread which is inside the runnable state, that means they are ready for execution with all resources. Okay. So all resources are available with the thread and they are ready for execution. So in runnable, one queue will be maintained. Okay. So as for data structure concept, queue means first in first out. So anyone who will be in the beginning of the queue will get the CPU first. Okay. Their run method will be called independently on the availability of the CPU. Okay. So any thread which is at the beginning of the queue will be selected by JVM and will be given CPU. Clear? Now the thread will complete its execution and will declare itself dead and will come to terminate state. Okay. If normal termination will occur after completion of the execution, they will come to terminate state by declaring themselves as dead. Okay. But there are number of steps are there or situations where a running thread will be told or will be make, they will come out of the running state to the block state. Okay. So how it will happen, let's discuss. So we'll consider one more example. Suppose there is a canteen in college. Okay. So normally what happens, now whenever the first year student will take admission, okay, now the first year students are in queue. Okay. All first year students are having equal priority. So now one first year student, suppose T1, is consuming or is getting the food from the canteen. Okay. So suppose there are a number of items are there. All items the T1 thread is getting, having the food and going out of the canteen. Okay. Now whenever any first year student is consuming food and one third year student will come. Okay. So third year student is having more priority than the first year student in institute. Okay. So what they will do now, due to the arrival of higher priority thread, now the currently running thread, okay, the currently running thread will be taken out from the running state and will be entering to block state. Clear? And that process is known as suspend. You are calling the suspend method to the currently running thread. During the middle of the execution, it will be taken out and will be entering to block state. Why? Because you are allowing the higher priority thread to complete its execution. Okay. Now after the higher priority thread will complete its execution, the resume method will be called for the block thread. Now the block thread will again come to the end of the runnable queue. This is what the meaning of suspend method. So due to arrival of higher priority thread, the currently running thread will be taken out from the running state, will be entering to the block state. Once the higher priority thread will complete its execution, now the resume method will be called for the block thread, and it will come to the end of the runnable queue. And whenever its turn will again come, it will go for execution. Clear? Okay. So this is one state. Second one, suppose any thread, so T1 is running. Okay, and let's consider the same example. Okay, so how many items are there? So four items are there. Clear? So one of the item is suppose non-veg. Okay, now T1 student is getting first one, second one, third one. Whenever the non-veg item T1 wants, now the item is suppose finished. Now preparation is going on. Okay, so till T1 is not getting this item, so T1 will not consume food. Okay, so that means for execution, T1 needs another resource which is currently not available because it is used by someone else. Clear? So T1 will not complete its execution, means it will block the CPU. Okay, so in that case, T1 will be forcefully preempted from the running state and will be entering to block state. Okay, so why this is happening? For that, wait method will be called. That means when wait method will be called, when a running thread needs some resources for its execution and the resource is not available, then wait method will be called for the currently running thread, which will come to the block state, and the next thread which is in the queue will come for execution or will be allowed for execution. Okay, now whenever the resource will be available, now suppose the item is ready, now notify method will be called for the block thread that the item is currently ready or the resource is currently ready. Okay, now T1 will have the resource and will come to the end of the runnable queue for execution. Clear? Okay, this is the third method. Now coming to the third one, the sleep method. Okay, now let's example consider the example of canteen again. Okay, suppose all first year students are standing in queue, one by one coming for execution or to get the food. Now suppose the canteen manager is looking after everything. Okay, now T1 thread student is coming, getting the food, terminate. Now T2, suppose T5 is at the end of the queue but violating the rule and coming here. Suppose now whenever T5 will come to get the food, canteen manager has noticed. So forcefully, by using their own power, they will call the sleep method. That means they will tell the student, you stay away from this particular, you will not get food for 15 minutes. You wait outside for 15 minutes. That means they are calling the sleep method to forcefully block a particular currently running thread due to some reason, and it will come to the block state. Okay, so sleep method is called to forcefully make the thread idle or to make it not running, and it will come to the block state for some amount of time. Now the sleep method takes some time in millisecond. Okay, once the thread will come to the block state, the timer will decrement. When the timer is whatever is set by JVM will become 0, now it will again come to the runnable state. Okay, so this is what the use of block state in thread life cycle. Okay, due to arrival of higher priority thread, due to the need of resources which is not available, and forcefully, all three types of methods are used to make a running thread to come to block state, and the resume is required to inform the block thread about the execution completion of higher priority thread. Notify is required to availability of the resources. Okay, to make the thread block from runnable. Okay. Now the last one is yield method. So yield method means what? Suppose all first year students, they are having equal priority. Okay. Now suppose thread T1 is executing or student T1 is getting the food. Now T2 is also having the equal priority. But due to some urgency or emergency, they are switching their task. That means T2 is also having equal priority along with T1. But due to some reason, T2 needs to execute first before T1. So we'll call the yield method to make the currently running thread to come to runnable directly. And T2 will get a chance for execution. And this happens when the priority is same. Okay. So to swap the execution or switch the execution between same priority thread, yield method is called by JVM. Okay. So this is what all the details of the life cycle of a thread, because one thread can be in any of the state in its life cycle. Okay. So through this video we have discussed regarding the usage of multi-threading and the thread life cycle. Okay. So in overview, if you need to understand why actually multi-threading is required, let me give you a simple example. Now threads are actually used in server side programs, okay, to serve the needs of multiple clients on a network or internet. Okay. So for example, suppose you are accessing Google. So Google is also having their server. Now you are not the only one who is accessing Google. Okay. You are sending some request. I am also sending some request. XYZ is also sending some request. So multiple people are accessing Google server. Okay. So on internet, what Google does, the server machine has to create the needs of thousands of clients at a time. So for this purpose, Google uses multi-threading for every request. Okay. For every request made by you or me or anyone, one thread, response thread, okay, that you can say a response thread is created to provide the service to every request. Okay. So which can do various jobs at a time. Clear? So for that they can also handle several clients at a time. Okay. This is one example. The second example for those who love to play game. Okay. So suppose one aeroplane is moving. Okay. And you are here, you are firing some bullet. Clear? Now see, in that particular game, one thread is required who will allow the aeroplane to move, and one thread is required which will allow the bullet to move. Okay. So that means by you need to do multiple tasks simultaneously in a single process. Okay. Otherwise you can imagine the game which will be designed where the plane will first move, then it will allow to fire the bullet, but that is not interesting. It will be interesting if both the tasks will be done simultaneously. So here also one thread is required to move the aeroplane, another thread is used to move the bullet, which will make the game more interesting and successful. Okay. So I hope that through these examples at least you can relate everything related to thread life cycle. Okay. So thank you everyone for watching this.